slides. So we'll just try to cover everything today
まあ、
as fast as possible.
今日で、できるだけ全てを要点をカバーするように話します。
Okay, so basically, this one is okay, so basically the Vedas have various additional supporting literature which are divided into phonetics, grammar, metrics, etymology, astronomy, and rituals. So one of those is Jyotish, astronomy, and astrology.
このベーダはその先生術とかそういうものをサポートして分かりやすくそういうものを説明しています。
Yeah, so six Vedangas or just limbs of the Vedas, these are basically dealing with all these different parts of either Sanskrit, like you see, phonetics, grammar, metrics, etymology, or the rituals or the astronomy.
ベーダンタの中に6つのセクションがあります。グラマーとかアストロジーとかさまざまなこれから話しますけど、6つのセクション。
Okay, so we see there was earlier the British would say that the ancient Indian sages had very, vast, brilliant imagination, and this is how they could conceive of various, calculations for the planetary positions and so on. But they pointed out kind of that they didn't have any instruments. They didn't, practically measure anything.
England and the modern age, they don't have
well, the British said that in ancient times Indians didn't have any instruments to measure.
昔はですね、イギリスの人たちが言ってるんですが、インドではそのような先生術として、言うわけですが、昔どうしてそんなものを測る道具がないのに、ここからここまでどれぐらいの距離があるとか、そんなことわかんないだろうと。
That they were just intellectually trying to, come up with certain, astronomical, achievements.
知的な段階ではこういうものを理解、説明してるんだろう。
That they were not really practical kind of.
しかしそれは実際的じゃないんじゃないかと。
Not very advanced, but that's not true because the astronomy was very advanced, and they definitely, we can see here, they had the instrument. Even nowadays, you can go to Jaipur, you can go to Varanasi, Delhi, you can, even in Ujjain, I've seen Ujjain as well. You can see these are very, very ancient observatories and various kinds of yantras, machines through which they would, calculate about the positions of the planets and determine their
しかし、それ
sizes
は
and so on.
それは真実ではありません。逆に実際的に非常にアドバンスした、発展したアストロノミーの、その道具があるわけです。それはジャイプロとかバールナシ、デリーとかのそのヤントラのその機械でもってそのホロスコープのその先生術が理解分かるようなものがちゃんとあるわけです。
So we can see that even in Kerala, in the 4th century BC, there was an observatory. 4th century BC.
4世紀 before 4世紀4世紀 BC で紀元前4世紀
Of course, that's what we know about. Who knows in the past how many have been there.
我々そういう時代を知っているわけですけど、
And Ujjain also is, it's renowned for being the, like the first meridian, basically from which everything else was calculated. So it's a very important place for astronomy.
ウジャイというところはそういうアストロノミーの先生がについて詳しく説明している重要な場所です。
And the present observatories have been built in the, Mathura, Varanasi, Delhi, and Jaipur by mostly Jai Singh. He was the king at that time, Jaipur.
マトゥラ、バンナシとか、ジャイプルとか、そういうところです。
So there are so many various yantras on instruments.
ヤントラでその道具として、それが道具となって測る方法があります。
So these are some of those quickly. We'll just list them. We won't talk about them. We'll just list them. We can read something.
まあ、早くこれを、まあ、
Shankuyashki, Shakala, Shakakayantra, Aryabhata, Chakayantra, Naivalya Dakshingola, Rasi, Valyas, Kapalyam. There's some of those that there is just used. So instrumentation definitely was there. It wasn't just some imaginary
ま
astronomy.
あ、ですから、こう想像したり、知的段階でそれを想像したというんではなくて、ちゃんとしたこのさまざまなものでもって測る方法の技術が経典から与えられる。
Okay, so the Surya Siddhanta is one of the very important texts, and we know that Bhaktisiddhanta Saraswati Maharaj, that Bhaktisiddhanta Saraswati, he made his own commentary on Surya Siddhanta.
まあ、それやセガンタという表現が我々のブルのバスンダマラキはそのところに解説を書いています。
So it deals with the various, astronomical points.
まあ、先生学の大切なポイントがそこにあります。
And it has been given by, I think Mayadana, I'm not sure now, or Surya Mayadana, something like that. So it's called.
スリア・マヤダナということについて、
And then, so essentially, there were 18 principal Siddhantas
まあ、18原則のセダンタ、その、
that were known. And then later on, Varaha Mihira, he collected 5 most essentials and he presented his work.
なんかミディアという方が、その中で
A summary of those.
5つだけ、そのとても大事なところを引っ張り出して、
Varaha Mihira was very famous astrologer in the court of Vikramaditya in Ujjain.
ジャーニのバランス
Minister.
バランさんという方は、大臣だったんですが、占いで有名な人。
He predicted that the king's son or the prince will die, will be killed by a boar.
まあ、王様の子供が死んでしまった。
And in the palace, they try to do everything to prevent that this doesn't occur. And the son is not exposed to any wild animals or go to forest or anything as such. But once, the wild boar, I think the iron, some kind of a image was there on the wall or something, fell down and killed the son.
まあ、なんか、棒って、イノシシだっけ棒。はい。あれは、アベがイノシシ。イノシシがなんか上の方から落っこってきて、子供の上に落っこってしまって、子供がなんか死んでしまう。
So anyway, became very famous. He was very brilliant, intelligent minister. He wrote many different kinds of treatises. So
まあ、そういう
he preserved those 5.
小さで、そのバランさんはその有名で、とても知性のある大臣で、そして、先生術を努力していました。
So then there is lot in Vedanta Jyotisha, which is part of the Rig Veda.
まあ、ビダンタジョーティっていうのはリグベダの部分です。
Has so many different, astronomical.
たくさんの先生学はそこに示される。
Okay, and then interesting things in Surya Siddhanta, which have been spoken, well, they say last compiled 1000 BC, Yes, so spoken by Surya to Mayadana, that's the king. So there are many interesting things, the diameter of the moon, the diameter of our planet. So it's practically the same thing what we know to be today.
それは、それは先生がとても昔からの、なんか古い時からそれが記述されている。
So this is what is interesting. That's the whole point. They exactly know, the size of our planet, exactly know the distances of the planets. It was exact thousands and thousands of years back.
何千年も何千年も前からこの宇宙のサイズについて、そして惑星のサイズについて、記述している。それはまあ現代の記述とすごく似ています。
So even formulas that have been used in the ancient times are far more precise than even the modern ones nowadays. So even the formulas that they use, the methodologies, in ancient times were far more better and precise, easier than what has been and is used today in the modern science.
formula.
Yeah,
formula.
calculations.
Yeah. Then today,
in ancient times, has been much more precise and easy.
昔の方が、その原則としては、それらの先生術のマントラっていうのは昔の方がもっと簡単にそれを測ることができた。
So we can see Surya Siddhanta compared to modern, it's pretty same.
今のそのセダンタ、その結論は、今のモーダーエイジの近代の数字と非常に似ている。
Okay, so interesting things that sages were aware of the distances of the sun and the moon and their diameters.
太陽や月やなどの距離。
So then the distances, the interesting thing is when the distances were measured, they were measured from Bhumandala. That's the point, not from our planet, but from the Bhumandala. So that's why most often people get confused, how come this distance and this and that. So that's measurement from the Bhumandala plane, whereas our planet is tilted. So it's not the same thing in that sense.
その距離の測り方はブーマンダラを中心に測る。
So these are the, we won't go into details now, just if you can see something in read, okay. So now about those distances, that's interesting that whatever nowadays the scientists are using, they use basically the point of the parallax. And using heliocentric model, the point is by using heliocentric model, all the planets are far more distant than what actually they are. That makes everything far more distant. Yes. By using heliocentric model. It means that the Earth goes around the sun.
専門学者たちは、その宇宙が、パラダックスって何だっけ？矛盾？
Anyway, there's various methods, like parallax is one which, for which they can calculate. We discussed this here a little bit. So parallax means the position of the Earth. That's what they, how they consider the Earth goes around the sun. So let's say they take India and they take US. So in January and June, from US or from India, then they, through parallax, they try to determine what is the distance of a certain star that they're looking at. So because the Earth is too small, so just by taking India and the US, for example, and try to create a parallax, you just can't get any distance. It's too short, it's too small. So then they take the kind of the orbit of the Earth, like this system, and they calculate the distance of that certain star.
そのパラドックスって矛盾？パラダックス。パラダックス。パラダックス。パラドックス。
No, not paradox. Well, it is a paradox.
The name of the star.
No. It's not the name of the star. Parallax is it's the distance.
Rail lines.
Rail line.
But it's not exact, so where it matches at certain points,
そうそう。パラダックスっていうのはその測る時のその線ですね。上から吊る下げてるんですけど、それを中心にこの回してその距離を測る。インドとアメリカだと距離が短いので、そういう大きな距離を測りながらこの距離を測るんです。
So basically using trigonometry to try to determine, if you know two angles, then you can determine the third one. So trying to understand the distance of the stars, this is what they essentially use this methodology.
ですからこう吊る下げて、上から吊る下げてその距離を測って、角度でもって星と星の距離などを測る。
So for 1 light year, that means our distance from planet to the sun. Let's say just for you get 1 light year, when is a year or a minute? I think 1 light year, yeah. So if you set up 16 inches, if you put two telescopes at a distance of 16 inches, and you try to determine the distance for, let's say, about 2,000 miles. That would be in India, like Mumbai, Delhi. You come on the highest roof, on the roof of some building, and you set up inches separated I mean, telescope separated for 16 inches, and you try to determine the distance of 2,000 miles. What kind of result you get? It's really, it's kind of absolutely impractical.
とてもいいこと。
Okay, let's say here, Japan,
まあ日本
Okinawa. What's the difference of Japan and Okinawa? What's the distance? How many kilometers? How many?
ここから沖縄までの距離って、
Anyway, it doesn't matter. Let's say, let's split it. So you count the roof of the temple and you put two telescopes. You know, the distance between them is 16 inches. So that's the distance between the planet in June and January here you see around the sun when you measure parallels. Like this. So to determine one light year, you know, that distance, can you by those telescopes using parallax figure out, Okinawa, like this distance of Okinawa? It's just even zero. Definitely there's going to be an error. It's not going to be an easy task. It's very difficult. You know, it's like it's a very thin point. You know, it's like a very thin point.
あ
It's
あ、
like this.
コスモス B。
Yeah, I mean,
まあまあ、
that's just one light year. And they talk about, you see, this is one light year. Then they talk about hundreds of light years. Then they talk about thousands of light years. Then they talk about billions of light years. I mean, hey, you know, it's too much.
うん
It's enormous speculation.
まあ、だから宇宙は非常にこういうふうな大きいので、そういう
It's too far out. It's far out.
あまりにも巨大であると。
Okay, anyway, it doesn't get too much. So basically, I mean, the old values and then the Doppler system, everything, it's just so failed. It's just such an enormous population, and the way they calculate distances. It's just too far. It's just makes no sense.
まあね、非常に距離があっ
Okay,
て、
but okay, you can give them credit for, but billions of light years and this and that. It's just too much.
ですから何千何万も何兆という距離とかを試作でもって測ることはこれはどうか思ってる。
Because the point is also that all the other methodologies that they're using, there are several of them, but they're all primarily based on these parallels.
まあ、ですからこういうふうなマントラですかを使って、そういうふうに先の方向で
Because from these closer stars, then they determine the distance of the, more distant ones.
近くに見えると非常に遠いものであると。
So
そう見
anyway,
えるわけですから、それをこのマントラとかで正しく測ることができる。
so we can again see Aryabhata was a very famous astronomer. So his measurements of the planets,
アイルバータという有名な人がいる。
distance of the planets from the sun, it's like it's very, very precise, amazing. He lives so maybe almost 2,000 years.
何千年前の人ですが、太陽と星々との距離などを正
Traditional
確に
great methodology. Then very famous one was Brahmagupta, another, so it's just accuracy, incredible accuracy of the Earth's position around the sun, or sun around the Earth, or taking
ブラマブッタさんという人が太陽と他の惑星との距離を正確に測った人です。
Okay, I know this is very technical, so I'm just skipping, just going quickly. So that's it. So a little more, just few more slides like this, and we're out. But the point is, if you look at these values, they're practically exactly the same.
実際的にその距離が
How
実
much
際
it
に
takes for one planet
近
to
代のやつと
complete its, cycle to complete its, orbit.
をオルスに
Yeah, so these are interesting things. Anyway, one more.
現代と昔と
Yeah, so there's another one. So that's the latitude. Deviation. Also came with some revolutionary conceptions. Talking about eclipses and thoughts, he also suggested, partial heliocentric model, for which we just criticized. But then, yeah, so they're very famous astronomers. They came up with a lot of interesting concepts.
まあこれ
Not
が
on their own, they use Vedic, scriptures.
They are not.
They're known nowadays because they used them.
アイデアの人たちがこ
So we'll quickly go through them. Bhaskara and a lot of interesting things. Anyway,
まあ、そういう機械道具がなくても、 違った方法で正
They
確
find a
に
lot of advanced mathematics within their astronomical works. They find calculators, they find so many interesting things.
数学者
Many thousands of years practically earlier than Newton or Leipzig or anybody else.
この昔のそのベーダ時代数学者が驚くべき計算方法でそういうトランプの
No,
条件を
mostly all of those have been preserved in Kerala. Brahmanas in Kerala were very advanced in this kind of thing.
まあそういう人たちはブラマー
Anyway, so there's so many. We won't mention several of them.
まあ本当にいっぱいいっぱいする人
So in Srimad Bhagavatam, we find the calculation of the time from the atom. That's something that's interesting.
はい。
Calculation of the time,
まあ今はバーガー見るほど時間については
atomic time. Okay. Anyway, so there's a whole description how that calculation is
経典に
made.
ブラマー、はい。
Anyway, so table of time in terms of the modern clock. So that's also time measurements.
まあ今の近代の時間の測り方
Okay. And then we see Uttara and Dakshina and solar movements, then millenniums, then different, we know the four yugas.
まあ4時代、夕方とか、
Then larger, then what is 1 year of the demigods.
まあ1年間が神々の1年間と口と
Then what is 1 day of the Brahma or the Kalpa then.
ブラマーの1日カルパマンがある
So interesting, all the time, divisions of the time.
まあとても興味深い時間の測り方。
And then duration of the months.
マンドの一生
After end of each and every Brahma's night.
ブラマーの夜が終わった夜。
Anyway, so that's pretty. So here we can see this is interesting. See how the time is divided. And life of Brahma is 311 trillion years
321
according
兆
to
円
from our point of view.
がブラマーの一生です。
Of course, for Brahma is also 100 years. His experience that for us is 100 years.
もちろんブラマーのその体験は100年。
So anyway, you can see this one. So then, so geocentric model, basically our is geostatic. Geostatic more precisely, Vedic model.
まあこれはとても昔のまた測り方。
You know.
データの方法。
So, but actually there is no really like contradiction between the geocentric model. It's just a point of the view. Interesting, Einstein, Mach, they point out that mathematically, essentially, there's no difference. Whether you view things from sun to the earth or from the earth to sun, mathematically everything is exactly the same.
まあその数学で測ると全くのその距離というのは昔測ったのと同じ結果が地球と太陽の距離。
So most of the physicists, astrophysicists, they just don't see any significance about it, any difference. Of course, except the difference is what we pointed out, that the distance of the planets can be much greater if you use heliocentric, so that's the problem.
まあそういうふうにして、まあ距離を。
So mathematically, there is nothing wrong with the geocentric system because we're observing from the Earth that it's relative motion that really matters. So if you assume the sun goes around the Earth, there's nothing wrong with this question of relative. So, whether you take
まあ数学自体が悪いわけじゃないんですけど、まあこういうふうにすれば、太陽の周りを回ってるわけです。
okay. So then day and night, how do we calculate day and night?
まあどうやって昼夜を測るでしょうか。
And the seasons as well. It's interesting that the sun has, sun has one lag, that means 100,000 different types of rays. It's not just gamma, ultraviolet or this or that. It has 100,000 different rays. And each month, each demigod or Aditya and all his assistants who keep on changing every month, they have about 8, 10, or 12,000. It depends, different rays. So these rays which have different effects. So this is how seasons are also affected. Seasons are changing. And then of course, depending on Uttara and Dakshina, we'll come to that. That affects the seasons.
すごく申し上げますけど、太陽がその光線が何百に百千で、ものすごい数に光線があると。で、神々がそれらを、コントロールしてるんですが、この月が変わるごとに、違う種類のその光線が現れる。それによって四季が変わります。
So it's interesting that the water is the fuel that keeps the sun burning. The sun collects the evaporated, water or the steam from the universe, and this is how it, it continues to create the energy according to that kind of electrical principle.
太陽で水を生産します。水を、蒸気にして宇宙に発散させて、そしてそれを想像して、維持しています。
And this is about the rays, so many rays.
たくさんの種類の光線の種類があります。
So not just thousands, there are 10,000. So these are mentioned in the Vedic scriptures.
ベーダの中でそういうことが書いてあります。
So there are different types of fire.
違う種類の火。
So Vaidut is more like electricity. So this principle actually is sun generates energy.
電気などもそうです。それぞれの個性的なエネルギーの種類があります。
So anyway, so point here is about the sun. Now we have to explain. So sun, goes around the jungle deep. He has two axes essentially. If you see the middle for the gray one, so two axes. You can see the wheel which goes on Manasotra mountain, Pushkar, and then the chariot is above the milk ocean, on which sun is saturated, and the other axis connects to Mount Med. So it's the same height, 84,000 yojanas, So wheel is on Manasotra and has three tracks. So moving on different tracks and moving by various speeds also simultaneously around, that creates different seasons. And day and night. And then the sun moves up and down, when it's up for 6 months, it's up, it goes like this. I mean, I have to show you, you can see now. It goes like this, it goes up, and then it comes down. It's like this, like spiral kind of stuff. So when it goes up and down, it takes 6 months. So when it's up, then it means it's a day. So 6 months, it's up, that's the day for demigods, that's Uttarana. When it comes down next to the wheel on that level, then it's Dakshinaya. It's only for 6 months. So then it's night for the demigods. That's why you have North Pole and South, you have like 6 months.
それで、
That's interesting.
太陽がぐるぐる回ってジャンドルビーターというところがあるんですが、3箇所に設定できます。一つはその中心の船のところ、もう一つはミルクローション、もう一つはメール、それぞれシーズンを作って、キャメトラインのその真ん中の軸が上がったり下がったりして、スパイラルにぐりぐりぐりと上がって、で一番上に上がると神々の6ヶ月。で、下に落ちた時には、ダキシナという神々の夜になって、それも6ヶ月。
So sun also has a certain range of the rays. So that's also what creates the day and night.
またその太陽がその光線でその夜とか日を作ります。
Okay, so eclipses. Eclipses, that is often the
What means eclipses?
Eclipse, eclipse when the moon is covered by shadow of the earth or the sun. And now they advertise some big eclipse in the US or something. People like seeing eclipses, but they don't know they're human species.
月が隠れるので、月食。
Eclipses are not auspicious at all. They shorten duration of life.
吉兆なんです。月が隠れる。
So one should not be exposed to any eclipse or looking at it.
それから吉だから吉が戻ると。
Because then Rahu or Ketu, 100 suns, Ketus, and one Rahu, of Simika. Anyway, that's one way.
100の最低の太陽がラフ一人いう大変です。なんだろう。そうだ、月の
There's a whole Quranic story about it. I won't get into it. So the point is that, Rahu's head body is the Ketu and head is Rahu. So
頭
they're
が
invisible
体
planets.
がケト。
They're considered to be the shadow of the earth. So basically, they're no different in that sense. So they sometimes come in the path of sun or the moon, and they create what is called an eclipse.
まあ、そのうちで結局、ラフが来た時に影になって月が出てます。
So now the eclipses could be accurately predicted for hundreds and thousands of years in advance when there was the science very astronomy.
まあ、ベディックのそのアストロノミーセンス実は100倍、1000倍、近代よりももっと明確に分かった。
So essentially, it is a shadow of the earth. So that shadow is Rahu.
シャドウイズバ
Rahu,
あ
Rahu,
シャドウはそういうラフという悪いやつです。
So when Rahu comes in between, then he is the cause of the lunar eclipse and mostly Ketu, I guess. Well, they interchange.
まあ、そういうふうにして変化する。ラフが増えれば、真っ黒になっちゃう。
Okay. So it's just more, very conceptually, just more personified. It's not just the shadow of the earth, but a certain shadow, a certain person behind the shadow. That's Rahu.
まあ、その影についてベディックではまたもっと説明しています。
So the moon phases also, that's one of the things that Prabhupada wanted to be explained through the Vedic scriptures.
まあ、月の影のデータで説明しています。
Yeah, so it's like a clock.
時計
It's
の
divided into divisions.
そ
All
の
the
時計がその次元を指して、違う次元を
and the
指して
sun travels through those.
太陽が旅行します。太陽の周りを旅行します。
And then the moon also.
月も旅をします。移動します。
So it's because it's a little slower, that's called the retrograde motion. It's called retrograde motion when the moon gets a little slower, behind the sun, so to say, to complete the orbit. So that's called retrograde motion.
まあ、月の方が動きがゆっくりなんです。
So different phases basically, decrease gradually, day by day, until the
だんだん毎日
light.
毎日少しずつ減っていく。影が増えます。
But actually, in Jyotish, Jyotish is mostly calculated by the orbits of or the traveling of the moon.
まあ、ジョティッシュという先生学では、そのムーンの動きについてまた説明しています。
Because the moon also has the shorter orbit. That's another thing, although it's slower, but it's shorter, but therefore it's much more precise compared to the sun.
まあ、太陽よりも月の方がもっとその軌道が小さいわけです。
Anyway, there's so many details, so we'll just quickly to this.
まあ、いろいろもっといっぱい。
So then sometimes what in the West they try to do, they will try to say, okay, fine, in Surya Siddhanta we find, there's a complete science, they can't deny it, it's just absolute science, which is equivalent to the modern results and all these versions of it. But then they will say, then Puranas are mythology, the Puranas don't match, it's just incompatible. But that's not true.
まあ、なんで結論はそういう、こういうもうこれは科学だと。それは真理から来ている。ですからそこは正確にそれが来ている。
Because Puranas the Siddhantas are just, technical, it's just technical information presented just for calculations, even just for calculations.
まあ、プラーナ古典ではそういうなんか結論書いてあって、その距離の案内が正確に書いてある。
Whereas Puranas also mostly deal with the cosmology that we had in the first part.
まあ、それがベーダの一番最初の方にそういうことが書いてある。
But even in the Puranas we find Siddhantas. Like few Puranas there are Siddhantas or same calculations mentioned.
いろいろなプラーナの中でもその結論というのはその書いてある。それぞれのプラーナの結論が一致している。
And so many other things which are exactly the same.
他のこともみんなその
This is
結
mentioned
論が
in the slides, so I won't read it. There is so much more. Yes, okay. We won't be to that. It's not the follow something like this. There are many details that point out to the same teachings of the information that are found both in the Puranas and the Siddharthas. They're complementary also. Like you can divide and say one is one. It's like you have, that logic of Artha Kumutunyaya, because had a head because it's eating too much, but then just in the back part. We can't do it. We have to take very scriptures are complete. We have to take everything. You can't just say I like this, I don't like that. Doesn't just because you don't understand how it works, that's a different story.
まあ、同じくこういうふうにインフォメーションがなんだかさまざまなプランによってある。だからその論理とかではだけでは分からない。データを受け入れて、一台ではそれに分からないので、データを受ければ簡単にそれがやりたい。
So it's interesting that that in various scriptures, even in Bhagavatam, there are different positions of the planets mentioned at a certain, important events.
まあ、シババダガではそれ同じように宇宙の惑星のそれぞれの位置が書かれている。
So in ancient times also, in order to perform certain ritual, which is part of the Karmakanda section of the Vedas, you have to be very well versed about the astronomy.
まあ、昔のカーマカンダの論理で、アストロノミーが面積ではとてもそれがちゃんと示されていました。
So that's another proof that the astronomy was very advanced.
まあ、それはもう一つのその証明になるわけです。先生的星座論についての証明となります。
And then even very prominent astronomers from the West of their time, they pointed out that the first known calendar in the world has been made in India.
まあ、ですから、カレンダーがなかった時もインドからそれをした。オリジナルでインディアン。
Yeah. So ultimately, why, like, I think you remember was the point. Who asked the question last time? Was the point? Yes, what's the point of studying this or knowing about cosmology and
まあ、そのコスモロジーの先生術のすごさですが、まあ、どういうふうに我々と関わるんでしょうかという質問をしました。
is that, confirm the time given in the scriptures of certain, epics like Mahabharata, or like in Srimad Bhagavatam, different stories, when they happened, where they happened. So that is what it means.
まあ、その時間調整によってそれをこうすることができる。マハバラタの。
So that's another hard evidence that points out to the authenticity of the scriptures.
経典の証明となるんです。時間を証明することができる。経典を実証することができる。
Specifically when we were talking about the beginning of Kali Yuga, they all use this date. Astronomers, Vedic astronomers, is a very important date. And what to speak of all these other events when they can determine certain positions of the planets in certain constellations at certain places.
まあ、ですからカリユガがいつ始まったのか、それをこのベディックなアストロノミー、先生術でこの先生学、星座を計算する方法で理解することができる。そしてそこで証明になる。その惑星の位置についてもそういったものを証明することができる。
So we really just rushed through it quickly. So just for the end now, we'll just show one little quick short clip video.
Video.
Yeah, that's it.
That's it.
So, really rough cut. So let's see.
シャストラからの星の文字。星の文字は先生術先生術ですかそれが
authenticity of these astronomical references. Dr. Hari Archer is a professor of physics at the University of Memphis and the world's foremost researcher of the astronomical events described in the Mahabharata text.
The Mahabharata, the date of it, is an important milestone in the chronology of India. Traditionally, Indians have believed that the war took place about 3000 BCE. Modern scholars who have a more critical approach to the study of these epics took a different view. They did not believe the traditional view that the war took place so long ago, and they wanted to determine the date by using a variety of methods based on linguistics, methods based on archaeology, the genealogy lists in the Puranas, and methods based on astronomy. And they came up with a plethora of dates ranging from around 5000 BC all the way up to 500 BC.
Professor Archer uses a specially developed computer software program that enables him to view the night sky as it would have appeared at any time in the past. He has painstakingly reproduced the exact night sky for every reference to it in the Mahabharata. Professor Archer again.
Turns out, the types of astronomical phenomena referred to in the epic consist of muhurtas, tithis, and then eclipses, comets, and conjunctions of planets with different stars, and so on. In the Vishnu Parva, Vyasa meets with Dhritarashtra on the eve of the war, and recites to him the omens that he has seen.
These omens predict the imminent war between the Pandavas and the Kauravas, and the terrible events which will befall both the Kuru family and the general population. The significance of these omens is the appearance of two fiery comets.
Graho Tamrarna Shikho Prabhui. People generally take the word Graha to represent the planet, but Vyasa here specifically represents Graha simply means that any object which can grasp a star, and it can be a planet, a comet, and an asteroid. He specifically says that it's a comet because Graho Tamrarna Shikho Prabhui. The two grahas with blazing coppery red hair. No planet has blazing coppery red hair, it's only the comets which have that. So Vyasa specifically refers to Graha, comets as Graha. Then I have that convinced that the verses in Vishnu Parva are really not incoherent, inconsistent, contradictory, but in fact they form a very consistent set.
Professor Archer has identified further astronomical references in two of the books of the Mahabharata, namely the Udyoga and the Bhishma Parvas. Again, these were regarded as omens of imminent disaster. These were when Saturn was at Aldebaran and Mars performed a retrograde motion near Antares.
Now, the astronomical events which are common to both Udyoga Parva and Vishnu Parva are these. Saturn is at Aldebaran. Mars has performed a retrograde motion at Antares. The lunar eclipse in the month of Kartika, which occurs at Pleiades, is followed by a solar eclipse near Antares. So I searched for the years between 3500 BCE to about 500 CE, a range of 4,000 years. Means there are 137 such conjunctions where Saturn is at one.
Here we see Saturn's transit at Aldebaran. It's an event which is even today considered by Indian astrologers to be associated with great wars and violent events. The last transit of Saturn at Aldebaran was in 2001 AD, the year of ground zero. Saturn's retrogression seemingly predicting the exact month, September. Professor Archer again.
And then I searched for those years in which Mars would perform a retrograde motion near Antares. Now Mars does that on about a synodic period for 680 days. So I searched for a period of 2.5 years on either side of each of these 137 dates. And it turns out that this reduces the set of dates from 137 to just 70. And then I looked for those years where there is a lunar eclipse in the month of Kartika, that is near Plains. And this reduces the set from 17 to just 2.
These 2 years identified by Professor Acha were 2183 BC and 3067 BC.
I thought I could use a solar eclipse to eliminate one of those, but it turns out on both of these days, the lunar eclipse is followed by a solar eclipse, which occurs in the context. In 2183 BCE, the winter solstice occurs in the waning phase of the moon, Krishna Panchami. And in 1367 BCE, it occurs in the waxing phase, and we want the waxing phase. So this is one way to eliminate that this 1367 BCE is the year of the war. For the 2183 BCE, to satisfy that 64 days between those two plots, the war must have started on Amavasya, for the new moon day. And we have definite information from the epic that the war did not start, or could not have started on an Amavasya, because on the 14th day of the war, they break all rules of war. The war continues in the night, and they break only when the moon rises and the wee hours early in the morning. Now, the war had started on an Amavasya. The 14th day would have been in the waxing phase, and the moon would rise early in the evening and not early in the morning.
Moreover, a careful study of the epic yields data about a third eclipse in October 3067 BC, which follows the solar eclipse at an interval of 13 days, just as the epic describes. The evidence presented by Professor Acha overwhelmingly pinpoints 3067 BC as the year when the great battle described in the Mahabharata took place. Detailed examinations of the astronomical references mentioned in the Mahabharata show that they were based on real astronomical events that actually took place and are not a writer's imaginary description. Perhaps the most significant evidence supporting Krishna's existence comes from the astronomy.
Okay, any questions? Comments?
質問とか言いたいことどうぞ。山田さん、聞こえますか？ハレクリシナ先生学、生学。Interesting because our depend on karma and birth, exactly time, place, time, time, and then our circumstances, and generally, if you know practice spiritual life, then fixing.
What is knowledge?
What is knowledge? Krishna defines knowledge in Bhagavad Gita.
まあ、知識とは何ですか？それはバーバーギターでクリシュナが答えています。
Do you have anything related to this? Or you want a related question?
Yeah, actually, earlier you told that there are 6 sections of knowledge.
No, these are Vedantas, these are parts. Knowledge is every Veda itself means knowledge. So these are just part of these parts of the knowledge, dealing with certain more, concrete or precise, topics.
まあ、知識は何ですか？その質問は今日のどこからの質問ですか？それは6つのセクションのアストロジーのことについてのこれは一部であって、ベーダは知識の
knowledge about astronomy and astrology, then this is Vedanta.
I can get this answer exactly from the Gita. So Krishna.
No, Krishna defines exactly what is real knowledge. It's his knowledge, but that is absolute.
クリシュナはこれらの知識ですが、真理の知識について語ってい
The
ま
more
す。
simplified definition of knowledge would be to know what is spirit, what is matter, what is controller, what is.
まあ、知識というのは何が物質か精神か、そして両者の関係者を知る
That's
こ
the
とで
real knowledge. If you know how to differentiate between spirit, matter, and who controls both. That is the man.
その3つです。それは、物質と精神の違い、その両者の管理者を知ること、この3つが究極的に知識です。
Yeah, okay, so that's a sign. So we'll stop here. So
これでコスモロジーがトゥデイで、ラストで、Thank you very much.
Okay.
ここで前作ったその宇宙の写真っていうか絵がありましたけど、ちょっと間違えてることもありましたので、また新しく魅力的な絵ができたので、それにもらいました。それをね、今度コピーします。欲しい人は、見てください。すごく面白いです。松屋が支えて、その上に像があって、その上に円盤があって、その上に像があって、そういうの説明があって、それをね、見本にします。
You can give me gift.
どうもありがとうございました。はい、クリシュナ。あなた、サニプラブキン、ジャイ。どうも、よろしく。忙しい。私。
Yeah, it was today and then again tomorrow.
But today, what did it rain?